Every creature on this planet has had millions of years to evolve alongside it. Fish grew gills so they could pull oxygen from water. Birds developed lightweight, hollow bones so they could take to the sky. Polar bears built up layers of thick fur to endure the freezing Arctic. And then there's humanity. We get burned by our own star. Our backs give out on us. Bringing a child into the world is so physically brutal that it claims more mothers than any other mammal species experiences. And on top of all that, we're the only creature that ever looked around at the planet it came from and felt like something was fundamentally wrong. So what if that feeling is correct? What if we don't belong here because this was never actually our home? Take a lizard. It can bake in direct sun all day without a second thought. Dogs, cats, horses, elephants, none of them need protection from the very star their planet orbits. Their skin, their coats, their biology, all naturally built to handle our sun. Ours simply isn't. We had to develop an entirely artificial product and physically apply it to our bodies just to spend time outdoors without getting damaged. Let that sink in. The fact that sunscreen exists is essentially an admission that our sun treats us like a threat. Here's another one: back pain. At some point in their lives, 8 out of 10 people will deal with it chronically. When a flaw shows up that consistently across an entire species, the problem isn't with individual people. The problem is with the underlying structure. Our spine was originally horizontal, built for a creature moving on 4 limbs, and evolution attempted to flip it vertical. The cushioning between our vertebrae wasn't designed to absorb the kind of constant downward pressure that comes with walking upright. Meanwhile, kangaroos and ostriches also don't experience this because their bodies were never repurposed. They were built for exactly the way they move. And then there's childbirth, which may be the most striking example of all. Across every mammal species on Earth, none go through labor as dangerous as humans do. The infant's skull is so large relative to the mother's body that passing through the birth canal is genuinely life-threatening. Throughout most of human history, before hospitals and surgical intervention existed, dying in childbirth was tragically common. No other species faces that kind of risk during a process as natural as reproduction. A mare delivers her foal in half an hour. Within 60 minutes, that foal is already on its feet. A newborn human, by contrast, cannot even support the weight of its own head. For months, we are, without question, the most dependent and helpless young of any species to have ever lived on this planet. Allergies deserve a mention too. The immune system exists for one reason: to defend the body. But in roughly 30% of people worldwide, that system spends its energy attacking substances that pose no actual danger. Pollen, peanuts, dust, pet dander, shellfish. The body is treating harmless things like mortal threats. That's either a significant evolutionary error, or it suggests that our immune systems were built with a completely different environment in mind. But the most unsettling thing about us isn't any of this. It isn't biological at all. It's the fact that we are the only living thing on Earth that is aware it will one day cease to exist. No other species carries that weight. A dog doesn't contemplate its own death. A dolphin doesn't spiral into existential anxiety. An elephant doesn't erect monuments to prepare for the afterlife. We do all of those things. Every human culture in recorded history has wrestled with mortality. We've built entire religions around it, written libraries of philosophy attempting to make sense of it. We've constructed whole civilizations shaped by the fear of death. From a purely evolutionary standpoint, none of that makes sense. Dread about dying doesn't make you faster or stronger or better at finding food. It's not a useful adaptation. It reads more like a symptom, the experience of a species that senses it is somewhere it doesn't quite belong, but can't identify why. And then there's the way we relate to this planet. Every other species fits into the ecosystem around it. There's a natural balance. Hunters regulate the hunted. Grazers regulate plant growth. Decomposers return everything to the soil. The system is circular and self-sustaining. We exist entirely outside that loop. We tear down forests. We foul waterways. We've altered the very chemistry of the atmosphere. We have erased thousands of species from existence and shown no meaningful sign of pulling back. We don't live within Earth's system. We override it. That's the behavior of something that was dropped here without instructions. An outside element that never learned how to coexist because coexistence wasn't part of its original programming. So if Earth isn't where we started, what is the alternative? In 1973, a paper appeared that, given who wrote it, should have fundamentally disrupted scientific conversation. The author was Francis Crick, the man awarded the Nobel Prize in 1962 for unraveling the structure of DNA, one of the most significant scientific achievements in human history. In collaboration with chemist Leslie Orgel, Crick introduced a theory he called directed panspermia. The premise was striking. Life on Earth didn't emerge here on its own. It was deliberately introduced by an intelligent civilization originating elsewhere in the galaxy, and there are reasons to take that seriously. Life on Earth dates back approximately 3.8 billion years. Earth itself formed around 4.5 billion years ago. That means self-replicating organic chemistry got started only 700 million years after the planet existed, a blink, geologically speaking, during a period when the surface was still volcanic and the sky was still toxic. The speed at which life appeared has never sat comfortably with biologists. Then consider the Murchison meteorite, a space rock that landed in southeastern Australia in 1969. Inside it, researchers identified more than 90 distinct amino acids, the same fundamental molecules that form the basis of all life on Earth. Some of them were identical matches, complex organic chemistry, traveling through the vacuum of space inside a stone. And survival in space isn't just theoretical. Tardigrades, tiny animals that look almost comically like 8-legged gummy bears, have been subjected to direct space exposure. They endured intense cosmic radiation and temperatures close to absolute zero. They lived. In 2019, a lunar lander from Israel carrying tardigrades failed on approach and crashed onto the moon's surface. Researchers believe some of those organisms may still be intact up there right now, dormant on the moon, waiting. Life is far more portable than we assumed. In 2013, ecologist Dr. Ellis Silver wrote a book titled Humans Are Not From Earth. In it, he gathered the physiological case that humans are simply not well matched to this planet. The UV sensitivity, the spinal problems, the immune overreactions, the lethal childbirth, and even the fact that our internal body clock runs slightly longer than 24 hours. His argument was that these aren't just evolutionary imperfections. They're evidence of biological origin elsewhere. Where it gets more complicated is that conventional evolutionary biology offers credible explanations for most of it. The framework is called evolutionary mismatch, and it's genuinely worth understanding. The back problems make sense when you consider that bipedalism is only about 6 million years old in our lineage, a very short window for evolution to overhaul a spine that was never designed for vertical load-bearing. We're running ancient hardware with a software update that hasn't fully taken hold. The sun sensitivity follows from the loss of body hair, which itself was an adaptation for long-distance pursuit hunting. Across open grassland in the African heat, bare skin and sweat glands made us extraordinarily efficient at staying cool over long distances. The trade-off was UV vulnerability. The childbirth crisis is a direct consequence of two competing evolutionary pressures, growing brains and upright posture, colliding at the pelvis, which couldn't satisfy both demands simultaneously. And the ecological destruction we cause is an almost predictable outcome of a species whose brain evolved to solve immediate local problems. In a small group setting, we suddenly found ourselves with global-scale power we were never wired to manage. Those explanations are solid. They handle most of the anomalies, but they don't handle everything. There's one piece that remains genuinely unresolved. The rate of our development has no precedent in the history of life. Dolphins have been swimming in Earth's oceans for around 50 million years. They are intelligent, socially complex, and capable of communication, and yet they have never, in all that time, fashioned a single object as a tool. Chimpanzees started using basic sticks roughly 4 million years ago, and haven't meaningfully progressed since. We, starting from similar technological ground, built nuclear reactors, launched satellites, mapped the human genome, and created machines that can hold conversations, all within roughly 2 million years. 200 years ago, there were no trains. 125 years ago, flight didn't exist. 75 years ago, no human had left Earth's atmosphere. 35 years ago, the internet wasn't part of daily life. The acceleration is unlike anything in 4 billion years of biological history. Nothing else has scaled like this, not remotely. Researchers have proposed various explanations: the emergence of language, dietary changes from cooking that supported larger brains, a key mutation in the FOXP2 gene tied to complex speech, and the development of cumulative culture, where each generation inherits and extends the last one's knowledge. All of these contributed something. None of them, individually or together, fully accounts for the sheer speed. Every other intelligent species evolved slowly, incrementally, over geological timescales. We effectively took over the planet in a moment. Crick didn't have an answer for it. Silver didn't either. Modern science can explain parts of it, but not the whole arc. The most reasonable conclusion is still that we evolved here. The biological evidence is strong, and the mismatch framework is legitimate. We are in all likelihood a product of this world, shaped by the same evolutionary machinery that produced every other living thing on Earth. But in science, likely and certain are not interchangeable. And when someone of Francis Crick's caliber, a Nobel laureate who fundamentally changed our understanding of life itself, reviews the evidence and concludes that something doesn't fully add up, that deserves to be taken seriously rather than dismissed, that's not the language of conspiracy. That's the language of a scientist being precise about what the data does and doesn't confirm. The impulse behind that kind of questioning is the same one that first made humans tilt their heads toward the night sky, the same drive that produced telescopes and space programs and interplanetary rovers. We are a species that cannot stop asking where things come from, including ourselves. Maybe that compulsion isn't a quirk. Maybe it's pointing at something. Because if this planet is genuinely where we originated, then we are the most inexplicable thing it has ever generated. A species that its own star burns, that collapses under its own planet's gravity, and that cannot stop looking upward, haunted by a question it can't quite form. And if it isn't, if somewhere out there is the place that actually produced us, then we've spent 200,000 years searching for it without even knowing that's what we were doing.